Welcome to the Cambridge Chemistry channel with Sarvat Ahmed. In this video I will be solving another titration question. A student does an experiment to determine the numerical value of x in the compound KIOX. A sample of KIOX is placed in a previously weighed container and reweighed. The mass of container of KIOX plus container is equal to 7.25. Mass of empty container is equal to 6.44 gram. Calculate the mass of KIOX used in this experiment. So by subtracting mass of container from the sample, 7.25 is the mass of container with sample. KIOX is equal minus mass of empty container 6.44, which is equal to 0.81. The student transferred the sample KIOX to beaker at about 100 cm³ of distilled water and stirred the mixture until all the solid has dissolved. The contents of the beaker are then transferred to 250 cm³ volumetric flask. The solution is made up to 250 cm³ with distilled water. This is solution J. A 25 cm³ portion of J is transferred to a conical flask. A few grams of potassium iodide and 10 cm³ of dilute hydrochloric acid are added to the conical flask. All the iodines in KIOX is converted into iodine molecule I2. Few drops of suitable indicator are added. 1 mole of KIOX react with Ki and produces 3 moles of iodine molecules. What apparatus should be used to transfer 25 cm³ of J to the conical flask? This is pipette. The same titration, first titration reading, second titration reading and third titration reading. 0.100 mole per dm³ of aqueous sodium thiosulfate is put into the burette and run into the conical flask. Sodium thiosulfate, whose concentration is this. 3 titrations are done. The diagrams below shows parts of the burette with the liquid levels at the beginning and end of each titration. Use the diagram to complete the results table. Final burette reading is, we have 23.7 and initial is 0.00. Second titration reading, final reading is 24.8 and initial reading is 2.0. And third titration reading is 32.9 and 10.3 initial reading. So this is 23.7, this is 22.8, this is 22.6. So take the best titration result. So best titration results are those readings which have smaller difference. 22.6 and 22.8, there is a smaller difference in between these two readings, so we select two best titrations. Take the best results, and using these results, the average volume of 0.100 mole per dm³ sodium thiosulfate is 20. Calculate 22.8 plus 22.6 divided by 2. This is, we get average volume, and this is about 22.7. Calculate the number of moles in the average volume of 0.100 mole per dm³ sodium thiosulfate. This is mole is equal to concentration into volume divided by 1000, because volume in centimeter cube. So concentration is 0.100 multiplied by volume in centimeter cube is 22.7 divided by 1000. This is equal to 0.00227. Now 2 moles of sodium thiosulfate react with 1 mole of iodine. Calculate the number of moles of iodine present in 25 centimeter cube of solution heated. 2 moles Na2S2O3 ratio iodine. So 2 moles react with 1 mole of iodine. So sodium thiosulfate moles are 0.00227 ratio x. So this is equal to, do cross multiply and we get 0.00114. 1 mole of KiOX produces 3 moles of iodine. Use your answer to E. Calculate the number of moles of KiOX in 25 centimeter cube of solution J. KiOX ratio iodine. 1 mole producing 3 moles of iodine, and iodine moles are 0.00114 ratio x. So this is equal to 0.0038. Calculate, using your answer to F, calculate the number of moles of KiOX in 250 centimeter cube of solution J. 25 centimeter cube contains 0.0038 mole. So what moles are present in 250 centimeter cube x? So this is equal to 0.0038 Using your answer A and G, what is A? Answer is 0.81. Calculate relative formula mass of KiOX. Mole is equal to, by using this formula, mass over mr. So mass is mr is equal to mass over mole. So we have mass 0.81 divided by mole 0.0038. So we get 213. So using your answer to H, calculate the value of x in the formula of KiOX. So KiOX is equal to 213, Ki 39, potassium is 39, iodine is 127, plus oxygen Ar is 16, x is equal to 213. 16x is equal to 213 minus 166. So this is equal to 166. 16x is equal to 47, and x is equal to 47 divided by 16. X is equal to 2.9, which is approximately 3. So the value of x is 3, and formula now is KiO3, potassium iodate. This is potassium iodate.